E-quip Math PD Series episode for Season 2.
And I'm Andy Albee. I am also very excited to be a part of this.
So Episode 2 is focusing on data, box and whisker plots, and then also graphs of central tendency. And like all of the topics from this series, this was chosen because it came up as a need through professional development surveys that we've done around Minnesota. So like we've said, Andy is here today as a facilitator. Also, I'm here, Amy, and then Patsy is here to share technical support, so she's the host.
Hello.
So, go ahead, Patsy.
Yeah, great. Thanks everyone for being here. I appreciate you taking the time for this webinar. There are lots of ways for you to participate today. It's going to be a very active, engaging hour here, hour and a half, and so we wanted to just give you a few kind of updates here as far as controls and such, just to be sure everyone's on the same page. So one heads up is that this webinar will be recorded. In fact, I'm recording it now. So just so that you're aware of that. And the reason we do that is for folks who weren't able to join us today can, of course, access the archived one later, and we'll post that to the Atlas website. Another feature we want to be sure you know about is the chat feature, and many of you have already found that, but if not, the dashboard or control panel on the right hand of your screen opens up. If you haven't figured out how to do that, it's an orange arrow, and if you click on the orange arrow, it either closes or opens a dashboard. Towards the bottom there, you'll see a chat box, and if the chat box has a plus sign next to it, you'll need to hit that plus sign to open it up, and you can type into the large box. If you just want to chat to one specific person, you can change that. It's right at the moment, it should say all dash entire audience, and so that means like right now what I'm doing is chatting to everybody, and so everyone will get the message you type. You can, however, during the webinar, if you have a technical issue, something that doesn't concern everyone, maybe your sound's off or you need help with something on the technical side of things, you can chat just to me, and you do that by hitting the little arrow next to the all entire audience sign there, and it opens up a drop-down menu, and you can click on my name, and again, I'm Patsy Vinogradov. So you can do that, or if you wanted to chat to one person in particular, you can do that as well. So that's a feature to be aware of. The other is how to raise your hand. We are keeping people muted just to keep background noise low, so if you need to speak up or if you're called on, we'll unmute you, but it's possible that you've already muted yourself, so just something to be aware of. The mute button is a green microphone, so it's where that orange arrow was at the top of your screen, there's a green kind of old-time radio show microphone there, and that will mute you or unmute you. And then if you want to raise your hand, keep going down those few buttons and you'll see a little hand there. So let's just try that real quick. Can people try to raise their hands? And make sure we're all on, yep, there they go, good. All right, perfect. I'm going to put all your hands down. All right, I have the power to do that, so there they go. So there'll be polls or tests, and that will be launched, and you'll see those in the middle of your screen. If you have, it looks like Mary's having some trouble hearing me, so Mary, if that continues, will you chat to me directly, and we'll see what we can do. Otherwise, it sounds like I'm not getting any other chats. I will also check my email throughout the webinar just to be sure if someone's trying to catch me another way that I am able to pay attention to whatever you need. So if you have questions, chat me directly, and I will hand it back to Amy and Andy.
Okay, thank you, Patsy.
Okay, and we're going to look through some ideas of what the objectives are for this. I'm sorry, go ahead, Amy.
Okay, so again, welcome everyone. I see people from all around Minnesota are here, and I also see some names from the current M&I cohort, and I just want to extend a special welcome to those participants. So specifically, the objectives for today, I'll read these to you. In order to improve instruction related to data, participants will be able to use the College and Career Readiness Standards as a resource for vocabulary and key focal points. Also, we hope that you will be able to explain data concepts such as central tendency, quartile, and weighted average, and then also explain some visual representations of data, such as box and whisker plots and stem and leaf plots. So that is the, we hope to accomplish all of that in 1 hour, and then after 1 hour we will stop the recording and then continue. Those of you that want to stick around will do some additional practice together. So as we go along, if you have questions, which that's great if you do, please just type them into the chat box and just chat to everyone, and we'll do what we can to answer them along the way. And then if, or if you would prefer, you could just jot your question down, and then at the end, before we start the extra practice questions, we'll answer the questions that you have. So go ahead, Andy.
So we want to take a look at what data is. And so we look at that just in the chat box really quick. If you could type in, when you hear data, what does that mean? Okay, good, Danielle, thank you. Good, yep. Okay, info, numbers, sets of information, sounds great. Yeah, so data is just information. It's something that we've collected somewhere. We've, of course, got big data stuff going on in the NRS and things like that. And yes, it's usually numerical, but it doesn't have to be. We're going to focus on the numerical today. And so where do we get it from? Well, we can get it from surveys, censuses, experiments, observations, just wherever we're trying to get some information out of. Organized, a lot of times we see it in lists, tables, charts, plots, graphs. The nice thing with plots and graphs is things are real visual, and that helps us to get the information quickly. And lastly, what are we going to do with it? How do we use it? We want to be able to make inferences and decisions to predict things, especially in terms of the GD test. They're going to be asking us to make inferences about the data in relationship to questions. So within this, if we have this term data and we know it's information, there are some vocabulary words that they're going to expect us to know, and we're going to start with some that everybody should be fairly comfortable with. The idea of mean, and mean is, of course, that sum of values divided by the number of data points, the average that we've done even back on the 2002 base test. The median, that's another one we should be fairly comfortable with. The idea of just the middle value or middle values of an ordered set of data points. Why would it be middle values? Why could we have more than one in dealing with that median if you chat it? Okay, yeah, if it's even, there's no middle. That's perfect, Paula. So sometimes we have to average those two middle values in order to get the median. And we're going to focus on median quite a bit later on today. And mode, that was the one that we kind of learned when we were back in middle school and stuff, the value that appears the most times. We're going to talk about that a little bit today, but it's really not that vital or not that big of a problem set on the GD test. Those of you that have taken the item sampler from GD Testing Service note there is a question in there that talks about mode, the one where you've got to add the data points in. So, we don't want to forget about it, but we're going to focus more on mean and median today. But there are some more data vocabulary that you should talk about. So minimum, of course, the lowest value, and maximum then would, of course, be the highest value, right? So not only knowing where the middle is, but where the highest and lowest values are within our data. Getting our range, the difference between the minimum and maximum, how wide is that value set, and just a couple more vocabulary words to hit on, and then we'll start into some work on some things. Who knows what quartile is? Have you heard the word quartile before? Okay, yeah, 4 sections, divide the medians in half, good. Yep, data divided into 4 sections, quarter or half. So it's the median of the lower half or the upper half of the data points, the quarter values. And an outlier, that's a data point that's significantly lower or higher than the other data points. And we're going to talk, there is a specific value that they tie into outlier that we want to pay attention to. Okay, there it goes. So now Amy's going to go through and talk a little bit about the weighted averages. So Amy, you got it?
Yes, thank you, Andy. I actually I muted myself and then forgot, so thanks.
Okay.
So these are the three topics that we're going to go into in more depth during this webinar. They're all GED topics, so that's why we chose these. So the concept of average, like Andy just kind of introduced, is, that's a topic that's pretty familiar to us, just average. And so with weighted average, that's a topic on the 2014 GED test, and that was new to me. I had to learn it or relearn it recently. And what I found was that initially I was really kind of overthinking it, making too much of it. And so, but once you just see a few practice problems, then you can see that it's pretty straightforward and a pretty interesting concept to work with your students. So a weighted average is just simply an average in which each item's contribution to the average may vary. So this first example I'm going to do is like I would say one of the most common ways to see this type of a problem. So I'm going to go through this very, very common example so we can all understand the idea behind it and then also understand the procedural steps, and then we can explore it a little more. So when working with weighted average, you're often asked to calculate a final score for a student. So for this particular student in this class, all of their scores don't count the same, right? So it looks like this instructor says that the exam and the final paper should really be most of the grade, right? And then quizzes count some, and then homework just counts a little bit. And then that circle graph that you see, that's just a reminder that when working with weighted average, all of the percentage weights will always need to add up to 100%, because what you're doing is you're constructing that 100% of the average. You're constructing that full average piece by piece, and some are just worth more. So if we look at this particular student's scores, it looks like this student maybe is a great writer. They got a 91 score on their final paper. Looks like maybe they missed a few homework assignments. They have their lowest score is in the homework category. But then to look at what does this mean, this just, in terms of weighted average, this just means that that score of a 70 counts for 10% of their score. Or a different example, the final paper, 91, that score of 91 would count for 35% of the score. So then the computation simply is to multiply each item, in this case the score, times its weight. So that 70 is then just multiplied by the 10%. And as usual when working, or how about often when we work with percents, we convert them into decimals first. And that happens here too. So each score is multiplied by its weight, and then once you have found each of those products, you just add them all together, find the sum of those products. In this case, it's 83 and 55 hundredths. So we're just going to round that, and we'll say that the final score of the student is 84. So again, that was the first full example. So this is a very common way to see weighted average, and you can see that you just need to simply multiply each item times its weight and then add those products together to find the weighted average. Okay, so now that you've seen that example, I want to explore this and point out some interesting things about it. So actually, average works this way too, the average that we're familiar with finding. And I just wanted to show you this so you can see that weighted average is not coming out of nowhere, but that it actually builds on ideas that we're already teaching our students. So here's a really simple average question. Find the average age of this group of students, and then it lists their 5 ages. So I imagine that many of your students would find this average age simply by doing what you taught them to do, which is add all 5 of the ages together. And then once you get that total, you simply divide it by the number of items in the list, right? So in this case, the 185 total divided by 5 items in the list would tell us that the average age of this group of students is 37. Okay, so this is what we are already familiar with. But now I'd like for us to approach this from a weighted average problem-solving perspective. So if we think of it in terms of weighted average, then what we can see is, in this case, each age counts equally toward the total average. So rather than having different weights, they all just contribute equally. So in order to make that full 100% of the average, each of the 5 ages would have to contribute 20%. So then if let's do that computation here, where we're multiplying each item times its weight, and then adding those products together, and you'll see that you'll still find out that the average age of this group of students is 37. So again, I just wanted to point this out, and this might be an interesting conversation that you would want to have with your students. That weighted average, it's not coming out of nowhere. It's really built on something that we're already pretty familiar with. And then just to make this link even more clearly, I want to just point out that that 20% weight that we used, that's equal to 1/5, and then which is also equal to that dividing by 5, which is what we did in the left-hand column. So there's your second example about working with weighted average. So actually, then I have a pretty great classroom example that I'd like to show you. But first, let's take a quick test. I want to make sure that you're keeping up here. So let's try this out. You should see a test on your screen. And it should ask a question, a multiple choice question about weighted average. So I see, great. I see that people are answering this question. About half of you have answered it so far, so I'll wait a couple more minutes. And what I'm asking about is what are the operations that are used for weighted average. I'd like to see a couple more people submit their answers before we move on. Okay, 2 more seconds to put your answer in. Okay, so let's look here. Of the people that submitted answers, it looks like 84% of you answered correctly. So my question was, which operations is or are used to calculate weighted average? And the correct answer is multiplication and addition. And I just wanted to do this quick test just to show you that although the concept may be new, the question type may be new, the computation behind it is actually pretty simple, pretty straightforward, and should be things that your students already know how to do. Let's see, Andy, I don't see the PowerPoint. Can you see it on your screen?
I've got it on my screen. I'm not seeing the test thing that you're talking about.
Okay,
what is
so
everybody else seeing?
So the test is closed now, and
Yeah, I think, Andy, I think you need to go click back on the PowerPoint for us. Sometimes after a test it's a little glitchy.
Okay.
Mm-hmm.
Okay, so is it showing now the classroom example?
Nope, maybe we'll just wait a moment. I don't see it. There it is, Andy.
Yep, thank you.
Mm-hmm. Okay.
Yep, thanks for your patience, everybody.
Okay, so for those of you that it took a while for the test to come up, I just want to let you know that we just kind of reviewed the idea that multiplication and addition are the operations that you need in order to find the weighted average. Okay, so now we'll continue with a classroom example. So I came upon this example as I was researching weighted average, and to me this just seems like a very engaging activity that could work for many level classrooms. So I'll walk you through it and be thinking about how you could do this in your class. So the example is to use weighted average to make a decision. So the decision that I thought of was, let's use weighted average scoring to help decide which of two cars to buy. So the first thing to do is, and then perhaps you could do this all together as a large group. First, list, when you're buying cars, together come up with a list of the qualities of car that you're looking for as you're making that decision. So the example that I have here, I chose reliability, gas mileage, cost, and appearance. And so then if maybe you're looking at two printouts of different cars, then you would rate each of them on a scale of 1 to 5, 1 being lowest and 5 being highest. So for example, car A, it has a really high scores for cost and appearance. So it must be a very reasonable price, and it must look great, but then have just like medium gas mileage and reliability. And then also, then I looked at another car B. So car B, it has great reliability. It looks like it doesn't really look that great, and then it kind of has medium cost and gas mileage. So if we were to just go back to the idea of average and then just find the average rating for each of them by finding the total and then dividing by the number of items. So car A would have an average rating of 4, and then car B would have an average rating of 3.5. So just using this information, it seems like car A would be the car that I would choose. But now then, once your students have learned how to work with weighted averages, they're able to put a little more of their own personality, their own values into this question. So then, and you can decide, maybe you would like to do this in small groups or individually. What you can do is weight each of these qualities, and in terms of how much does that matter to you. So the way this is weighted is that the reliability and gas mileage is going to be most of what matters the most in choosing cars. Appearance matters, but just a little bit, and then cost is kind of like medium-low. So, and then again, you just always make sure that those percentages add up to be 100%. So let's use what we know, use multiplication and addition, like we said, to compute these weighted average scores for car A and car B. So again, we're multiplying each rating times its weight, for car A, adding the products together, and then you'll see that the weighted average score for car A is 3.6. We'll do the same for car B. So car B, again, we are multiplying each rating times the weight, and then we are taking those products and we are combining them together. And here I see that the weighted average score for car B is 4. So if we look at our weighted averages, which actually more accurately reflect what we care about in choosing a car, car A has a score of 3.6, and then car B has a score of 4 out of 5. So since 4 is greater than 3.6, it looks like the decision in this case would be for car B. And to me then what's interesting is that if we go back to our original ratings, it looks like that car A was going to be the best choice. But once we put our individual weights on each of those qualities, then it turns out that actually car B is the best choice. So now that we know about weighted average, just regular average isn't always necessarily the best way to gather this information together. So again, I thought this was a really fun and engaging activity that could work in a lot of classrooms. And I'm just curious, I wonder if you could chat some different contexts that you could use, in which you could apply this in your class. So rather than deciding about cars, what are some other ideas that you could, some other contexts where you could use weighted average to make a decision? Can you think of any? Just chat those in the chat box. And while you're chatting, I want to add this. I like this activity because there's so much computation that you can review along the way that's embedded in here. So I see people are saying cell phone plans, what vacation to go on, health insurance plans. These are great ideas. Oh, how to choose daycare, how to choose a realtor, which sport should your child be in. Yeah, this is great. So again, I just think this is a very engaging way to work with students with math. Okay, so thank you for your great ideas that you chatted in.
Okay, and yeah, I love those examples. Oh, what brand of ice cream is best? Absolutely, got to get those qualities of what I really like. So we're going to move on and hit the next couple of ideas here. And Amy's set on the weighted averages had some really good work towards the GD test, but it wasn't quite as visual. And a lot of times when we're talking about data, we have visuals. And you can see these on the math test, on the science test, on the social studies test, and they're all ones that we're fairly familiar with, that line graph, the bar graphs, the circle graphs, to be able to gather that information out of. And these are very good representations of data, but they're not the only ones. And there are times when we want to have a little bit different representation. So when we look at a stem and leaf plot, we want to think of how do we do this, okay? The idea of a stem and leaf plot, it's a way to just organize data to be able to see that distribution. And two of the CCRS levels that hit this pretty hard is that we need to recognize that a statistical question has one that anticipates variability. So if I asked everybody, like, what is the temperature outside, well, that would have some variability because people aren't in the same place. But if I asked everybody what time it is right now, there's not really variability there. There might be variability in your clocks that someone might be set a little bit fast or a little bit slow, but really there's no variability. It is 3 o'clock. But if I ask people some other questions, how many years have you been involved in ABE, what's the temperature outside where you're located. There is some variability there. And so the CCRS is saying our students need to be able to recognize that and account for it. But also we need to understand that data can have different distributions in its center, in that mean, median, and mode, but also in its spread and its shape. Where is more of the data collected? And that's a really good thing that stem and leaf plots allow us to do. So I asked some people, I was at a conference over in Chicago this week, and I went around and just asked people, how old is your house? And this is some of the data that I collected. And I know it's kind of running together, but they're in groups, so it's 26 years old, 73 years old. Kind of in the middle there, you see 108 years old. But as I got this data, it really doesn't tell me anything because it's all jumbled up. So the first thing we want to do is think of, well, just like we would do on any other problem, we want to get this into some sort of order so we can start to see it. So in this case, we can see that youngest house for the people that I talked to is only 2 years old. They're living in a really new house. But we have some people there from some older cities, like one of the people is from Boston. You can see hers was fairly old out there at the 121. So once we've got them in ascending order, we can start to see a distribution here. But we want to put this in a way that makes it even more dramatically identifiable. And so what we're going to do is we're going to plot these points in. And if we look at that data where we started with at the beginning, we had some of the houses that were less than 10 years old. And so when we look at this house of 2 years, 7 years, and 9 years, they are not even 10 years old yet. And so the stem and leaf plots, we have a stem out here which tells us which version of 10 we're talking about. So when we're looking at that first stem line, it has a 0 for the 10s, but then 2, 7, and 9. So there's 3 data points within the 0, the units version. Our second row talks about the 10s. But notice on the leaves, we don't have 13 or 13 or 14. They just take the 1's number and attach it to the stem of the 10. So if you could chat, tell me which numbers, which values have a 10's value of 2 in this plot. How old are the houses that have a stem value of 2? Okay, can we, oh, there we go. Good, good. Yeah, it is that 22, 26, and 29 because the 2 goes with it on each one of those things. And so there's 3 houses that fit in that 20s age. Okay. As we're looking at this then, we can also start to see a little bit of the distribution. Is there anything that you're noticing in the distribution of these numbers? The mode of 110s. Okay, most are under 40 years of age, that's right. And that's where we see heavier on the younger houses, a lot at the beginning, and just a few out there towards the end. Good, Carol, that's an excellent point there. Notice in the 90s and the 100s and 10s, there isn't anything. And so we don't put a 0 there to designate that there's nothing, but notice in the stem of 6, there's a 0, so that means that there's one house that fits in the 60s, and that is actually exactly 60 years old. So each leaf is a separate data point. Okay, so the stem of the plot is the 10s, and the leaves are the 1s units. So based on this data, can we see from this stem and leaf plot what the mean is? Is it easy to identify what the mean is in this one? Okay, yeah, right. No, it's not easy to see the mean here. We would still have to go through and do the full calculation of, add them all up and divide by the number of data points and et cetera. Okay, what about the median? Is it fairly easy to find the median here? Kind of. Okay, I mean, it's not super hard to find the median, but we'd have to still kind of go through and find, count up the number of data points and find the middle, stuff like that. But it's not something that I can just glance at it and bang, I've got it. It's super easy. Okay, but we can find it. But what about the mode? Okay, yeah, the mode is really pretty easy to find, and someone was talking about it earlier. In this case, the houses had a bimodal situation, right? We had the 13s in there twice and the 37s in there twice. So having it in this form where it's all grouped in by tens, sometimes it's a little bit easier to find those modes than if they're just all listed out like they were at the bottom of the screen before. Okay, but what about the minimum? Well, sure, the minimum's just that lowest value, 2. And our maximum? Okay, someone want to throw in? Yes, okay. Do note that it's that 12 in the 10s, so it is 120 and the 1 tied on. So it's fairly easy within the stem and leaf plot to find a mode, to find a maximum and a minimum. Okay, what about the range? Well, the range is simply just the difference between the upper, the maximum and the minimum values. So we do have a little bit of a calculation here, but not bad. It's just the 119 years. And our quartiles. Okay, now we haven't really brought up quartiles. We brought them up in the idea of the definitions of vocabulary earlier. But can you just readily, looking at this, figure out where quartile 1 and quartile 3 are? Yeah, I agree, Rebecca. It's not something that just seeing the numbers up here, that those just pop right out at us. So they're not easily discernible, but they are. You still can find them. We can go through and do that. And then the last thing, the distribution, we talked about that a little bit earlier. Yeah, it's a little easy to see. As was stated earlier, almost all the houses are less than 40 years old. So the stem and leaf plot is designed or set up in a way to try and make it a visual way for us to find some types of information quickly, but not necessarily all the types of information. So why would we do this? What's the point for our students? If a particular stem has many leaves, we know that each data point represents that version of 10. So just like we were talking about the 22, 26, 29, sometimes the students can get a little confused on that. So we want to make sure we highlight that they don't miss that idea. They're usually written left to right, so don't worry about them being written up and down, because we want to read them just like you'd read the number. And it's a way to show the data in a somewhat graphical manner, right? We still have kind of almost like a bar graph thing going on, but we don't lose the actual data points. Okay, you can still see all the data that was created to give you this stem and leaf plot. And lastly, it's a good way to see the distribution, but not necessarily a good way to see like that mean and median. Median, again, not necessarily hard, but it's not necessarily overly easy here either. So what type of questions could we have here? Okay, and Amy brings in, what could we use to describe or define the word distribution? Okay, distribution is the idea of how the data points fit within the entire range of the data. In this case, the distribution tends to be skewed, in this case, up because it's near the top, but more of the data points are up near the earlier years of the age of the house, and fewer of them are way out towards the end. A lot of times we'll get data that is distributed fairly evenly and you'll get most of the data kind of in the middle and just a few things on the lower end and a few things on the upper end. But that doesn't really connect in much with this particular data. So I'm going to go ahead and launch a test here, but I want to ask you to kind of keep an eye on this, and we'll pop it back up here. But how many houses in this distribution were less than 20 years old? Okay, so that might be a type of question that they see on the GD test. Okay, that's how I'm getting it. Okay, Stemleaf, launch. Okay, are you guys seeing the test come up? It's not showing up on my screen. Okay, thank you. Yeah, there's 7 of them that are less than 20. A really common mistake for students to look at here is to see the 20s and pick up the 3 that are in the 20s, or try and include those 3 in with the 7. Oh, thanks, Amy. Okay, so I'm going to go ahead and close that test. And if we share that, yes, 83% of you answered correctly that it's 7. But notice the 10 was because we included the 20, and the 14 would have been if we had, if the students had accidentally looked for the houses that were more than 20 years old rather than less. Okay, everybody seeing that one? Okay, I'm going to go ahead and take that one off. And another type of question, we'd ask, what is the oldest house in this survey? And I think we've already hit that one. But making sure that...
Andy, yeah. Excuse me. I think you just need to hit go back on the PowerPoint again.
There we go. Sorry, when we go to a test, it turns my screen off. I got to remember to turn that back on. Thanks, Amy.
Sure.
Okay. Yes, the 121 is the oldest house. It's really common for students to mistake that 12 up front, but realize that that's 12 in the tens column. It's 120. And then the last question here, if Dave would flyer a neighborhood for furnace, if more than half the houses are between 30 and 60 years old, in this neighborhood, would he distribute flyers? A pamphlet, Danielle. Oh, yes, and it's a new verb. Thank you. Thanks, Jeannie. No, no, he wouldn't, because the distribution is showing that many of the houses are younger than 30 years old, probably aren't going to need a new furnace yet. And the ones that are really old aren't going to use furnaces. They're going to use, like, boilers and things like that. So in this case, yeah, Dave would not spend his time in this particular neighborhood. Okay, so that kind of gets us a feel for those stem and leaf plots. We'll have some extra examples out in the question and answer towards the end. But jot down any questions if there was something that I did that didn't make sense. And the last one we're going to look at is another visual way of looking at data, and it's what's called a box and whisker plot. And this was really designed back in the 1970s, so it hasn't been around as long as, okay, oh yeah, if they don't know what a furnace is, that might be difficult. So you might have to be sure of checking in on your, someone asked a question about it being a furnace. So make sure that your students understand that vocabulary. But a box and whisker plot is just a graphical representation of data, and it shows the minimum, the maximum, the range, and the quartiles of the data points. But this one comes right back into that CCRS level that it says we want to find its center, its spread, and its overall shape. Notice this one really doesn't bring in as much of the variability or the averages and things, but it does still fit into there. You just have to pay a little bit closer attention to it. So what if we asked the staff on adult academic program how long they've worked in ABE? And I did. And so I got this data. So again, if we're looking at that data, and I think we can see the separations enough to get the numbers, is it easy to find kind of the minimum or the maximum or the mean and average? Well, just like any other data, if we get it all in this raw form, it's hard to make sense out of it. So what if we turned it around and put it back into order? So we have a wonderful new teacher this year who's got her 1 in there for the 1 year involved. And we've got some teachers that have been here a little bit longer. And this was all staff, so I keep saying the word teachers, but some of this is not teachers, it's just staff. So when we look at this one, can we find that data? Well, not quite as hard to pull up some of those points. So we can find the median of this data by just finding the middle. And in this case, 23 people have responded. So the median value is right in the middle of those, the 12th position, and that's 8. Okay, so there's the median of our data. So what if we wanted to find out where the quartiles were? Well, all we have to do is look and say, there's 11 data points either below that median or above that median. So then we just need to find the median of those 11 data points. And the median in the lower half is the 6th number, which comes up to 5. And the median of the upper half is 6 more than that median, 6 more than the median of the whole values. The 18th data point, which comes in to be 13 years. Okay? How we feel on this? Is this making sense? Should be all okay? Yep, good, thank you. Okay, so these points now divide the data into 4 regions, or 25% of the data, and that's why we call them the quartiles. So as we're looking through that, then sometimes we want to take a picture of it in ways, rather than just having all the data, putting out there in the mean and median, all that, we want to draw this box and whisker. Now, the idea on the GD test is that it's extremely unlikely that your students will be asked to actually draw it, but they will be asked how to identify it and use it. But drawing it's going to help us to do that. So the first thing we're going to do is we're going to draw a box from the quartile 1 to the quartile 3 values. Oh, yes, it is, Amy. But she said it's a great connection to other parts of mathematics, just using that term where we hear the core in it. So on a box and whisker, we start with our box. And our box is from the lower quartile, quartile 1, to the upper quartile, quartile 3. And then right in the middle of that box, we're going to draw in a line for our median. Okay, so the 8 comes in and we get the median value in there. And so now it kind of looks like a box subdivided into 2 smaller boxes. And then we're going to draw the whiskers out to the minimum and the maximum values. And these are all drawn basically like on a number line. So they are proportional to the length of the area. So we can notice here in our lower chunk, our first 25%, we are anywhere between 1 and 5 years. Okay, so I just pulled that same box and whisker graph, pulled it down towards the bottom so we can get some questions. In this box and whisker graph, once all the data points are gone and all we see is the box and whisker graph, can you find the mean easily? Okay, I have students do the number line first. It's a really good idea, Carol, because it gets them used to that idea of distance relating to numbers. Okay, but if we're trying to find the mean of this, it's just not there, right? In order to find a mean, we have to have the sum of all the data and divide it by the numbers of data. And the students might want to take the 1 plus 5 plus 8 plus 13 plus 17 and divide it by 5. But really, that's not what this graph does. BoxWhisker Plot is not going to give you the mean. But what about the median? Can we get the median out of this? Well, sure. It's right there in front. It's the middle of the box. It's the 8. That's where that one came from in the first place. When we look for the mode, okay, Danielle brings up a really good question. I'm going to answer that question in just one moment here, Danielle, because that's a great thing to throw in. On the mode here, again, since we don't have the data points originally, we don't know how many fit into a particular data point value, so we don't know the mode. But the minimum and the maximum are all fairly easy because they're the ends of the whiskers. The range is, again, not that bad. It's just from the very end, the 17, back to the very beginning, the 1. So we have a range of 16. And the quartiles in this one, unlike the stem and leaf plots, are really easy to find. They're just the ends of the box. So 5 and 13. And this is a spot I want to stop for just 1 second before we hit that distribution question, and that's going to answer what Danielle brought up earlier. And that's that when we look at this graph and we see the box, and the ends of our box are 5 and 13 for quartile 1 and quartile 3, that is something that we call the interquartile range. We didn't bring that up in the vocabulary, and I'm sorry, I forgot to put that one in. But the interquartile range is going to be really important for us to help find an outlier, if there's any outliers on this one. In this case, there is not. And we'll pull up how do you tell that outlier in just a second. But if we look at it in terms of distribution, Danielle had asked in there, when we get the chat back up, so if the box, the quartile is small, that means there's lots of data points in there. And she's right in that one. The narrower the box, the tighter your data point distributions are, because each portion of the box contains 25% of the data. So 25% of the data is between 1 and 5, 25% of the data is between 5 and 8. So there are the same numbers of data points between 1 and 5 and between 5 and 8. It's just between the 5 and 8, they're kind of squished together because there are more data that fit within those range of 3 rather than between the 1 and 5, the range of 4. Okay, so bigger box, longer box between the 8 and 13 means we had to go further out into the data to get the same number of people. Okay, Danielle, does that answer the question? Does that make sense? Bigger box means more spread. Okay? And I'm going to back up just one section here where we see those quartiles, and we talked about that interquartile range between the 5 and 13, and I brought up the idea of outlier. An outlier is considered a value that is more than 1.5, the interquartile range, above quartile 3 or below quartile 1. So that can be really tricky for students to grab a hold of. The basic idea is it's something that's like way out big or maybe way in small. So if we looked at the interquartile range here from 5 to 13, that's a distance of 8. And so if we had any data points that were more than 8, more than 13, so it'd be out at 21. If we had anything that was more than 21, like 22, 23, 24, those would be outliers. because more than 12 more, because it's 1.5 the interquartile range. So I wouldn't put in too much weight into that, the outlier of getting them to be able to calculate exactly what it is, but just let them know that it's something that's like way out there big or way in small. Okay, so what type of questions could we ask about this? And I've got a poll question here I'm going to pull up, and I think I want you to look at it here, and then I'm going to pull it up. So based on this graph, let me pull up there. What percent of the staff at adult academic program have been with the program for 5 years or more? Okay, so I'm going to pull up that test. Oop, except it just went away. I'm sorry, I can't pull it up now. We'll just chat it. So what do you think? What percent of the people have been in the program for 5 years or more? Go ahead and answer that in your chat. Okay, so yeah, 75% have been there more, because 25% is less. She wants to see the numbers again. Okay, and Laura, that's a thing that we have to be a little careful with. On the GD test itself, the likelihood, if they give you a box and whisker graph or box and whisker plot, they're not going to give you the numbers. But if we look at this plot, we can see that 5 is the number for quartile 1. And so 25% of the people have been between 1 and 5 years in that first whisker. But that means that 75% have been on the other side, have been more than 5 years. And that's where we use the box and whisker, so we don't have to write down all the data points. It's a brief kind of like snapshot picture of it. Okay, Amy, is that you? Okay, and then last question here. If there were 23 respondents to the survey, okay, now at this point again, we don't have the data points themselves. Okay, we're not going to be given the list of all the data points. But if we see this box and then we're told there's 23 respondents, how many of the staff have been with the program for 13 or more years? And again, I have a test for this, but for some reason it's gone from my sheet. I think I closed it and I can't find it. Good, Renee. Okay. If we look at it, it's the people that have been with the program for 13 or more years is 25%, because it's from that quartile 3 up to the maximum. And 25%, or 1/4 of the staff of 23, would have been like 5.75. Okay, but we can't have 0.75 of a person. So the people that would fit into that upper range up above there would have been 5 people. Okay, so I'm seeing a lot of 5s on there. That's excellent. Okay, and that gets you at least a brief picture of both the stem and leaf and of the box and whisker. So Amy?
Okay, thank you so much for that explanation, Andy. This, I feel like we just had a very fast hour go by.
Yeah.
So that's actually the end of this episode, and I want to thank everyone for attending and remind you to go ahead and either right now or very soon within the next few days, Episode 3 registration will be open on the Atlas website. and you can see that is December 17th, and we will be, Andy and I again will be presenting about ratios, rates, proportions, and scale factor. And just because you're here and you can hear this, I want to let you know we put in little reviews that you'll receive in your registration email about ratios and proportions. So then we hope we can spend the most of the time of the webinar on the rates and scale factor, the more, more challenging concepts. So please feel free to stick around now, though, because Andy and I are going to be here doing practice questions for an additional half hour. And we have some planned, and we can also take your questions. Andy, could you just advance the slide, please? Okay, so just please register for the next episode, tell your friends, bring a friend next time. Thank you very much. So Patsy, if you could just please stop the recording, and we'll keep practicing for a half hour.
Will do. Thanks.